So these water cycle notes are going to supplement what we've learned or talked about and discussed in our water cycle game. Look at this diagram here. This is meant to summarize some of the processes or some of the actions that water takes as it moves through the water cycle. And a lot of this is review. For example, we know that water can evaporate, goes up into the sky. That was a review from transpiration, the fact that plants release water into the air. Condensation, we know that the water gets up in the air, gets cold, and it sticks together. And then it finally falls out of the sky, comes back down to the ground as precipitation, whether it's rain, sleet, snow, or hail. Now, we're going to look at what does water do once it hits the ground. The first thing that water can do is it can become what's called runoff. And this is water that when it hits the ground, it moves across the surface. Think like a river or a stream. On the other hand, some of the water that comes back down to the ground actually goes into the ground. We call that infiltration or percolation. And those are the two new processes that we're going to look at now. Fall semester was all about what was water doing in the air. Now we're going to look at it. What is it doing when it gets on the ground? Storage. Storage describes any of that water that's down here on the ground that's just sitting in one place, whether it's like frozen in a glacier or it's just hanging out in a lake or a pond or stuck in the ocean. Well, now let's look at where is the water distributed. We saw a bunch of different places that it can hang out, a bunch of different places it can go, and now the actions it takes to get there. Well, I'm going to visualize this for you. I want you to imagine that a 2-liter bottle is every drop of water on the planet. Remember, all the water on the planet has been here for about 4 billion years. So it's all here. It's just a question of how much is at which different location. And that's what we're going to model here. So if 2 liters is all of the water on the planet, 1.944 liters, or 97.2% of it, is found in one particular location. Well, where is that location? And that's most of it. 2.8%, or this 56 milliliters, is found somewhere else, and 2.3%, 0.4%, and 0.05%. Well, what places has that amount of water, of our water? Well, the 97.2% you might have guessed. 97.2% of all of the Earth's water is found in the ocean. It's salt water. And that's important because salt water really isn't useful for us. We can't drink it. We can't water our crops. We can't use it for any kind of resource. So this is kind of profound because 97.2% of all the water on the planet, even though we live on a water planet, most of it is not useful to us. Now, 2.8% must be fresh water, water that is not found in the oceans. So there's a visual for you that graduated cylinder right there, that's all of the water of that 2 liters that is useful or fresh water. Now, where's non-salt water found? Well, glaciers, lakes, ponds, swamps, rivers, streams. It's all the water that's not in the oceans, including water that's under the ground, which we don't normally think of because we can't see it. So, of my 56 milliliters of water that is not salty, water that I can use, 46 of that 56 is found in one location, and that's in glaciers. Now, the trick is with glaciers, that water is frozen in place. And if you don't have a glacier close by, that's not water that you can use. Well, where are glaciers? Well, glaciers aren't found everywhere. Most of the glacial ice is found in Greenland and in Antarctica. Well, nobody lives there. That means a large portion of the Earth's fresh water is basically useless. It's not useful for anybody because nobody lives there. It's frozen in place. It's not like it's flowing. So these other two graduated cylinders, the 8 milliliter and the 1 milliliter, that's basically all of the usable water on the planet. And you can see, think about this, 8 milliliters plus 1 milliliter, only 9 milliliters of my 2-liter bottle is really water that I can get to, that I can use, that is helpful to me. Well, The 8 milliliters represents groundwater, and the 1 milliliter represents surface water. So of my 2-liter bottle, that represents every lake, river, stream, pond, swamp that you and I see. There's actually a lot more water under the ground than is on the surface, but we don't realize that because we don't see it because it's underground. So we're going to make some conclusions, and we're going to write this on the bottom of our note sheet. What are some big ideas that I now want you to know about water and where it's found? First of all, 97% of all the Earth's water is salt water, which means it's useless. Secondly, most of the Earth's fresh water is in glaciers, which once again doesn't really do us any good. Finally, there is a lot more water underground than there is on the surface. Those are the three big ideas that are going to drive our discussion going forward.